This tutorial is going to cover how to factor quadratics, and it goes along with lessons 21.1 and 21.2. So basically, what you are doing is undoing FOILing from a quadratic that's given to you in standard form. So remember that standard form is when we are given ax squared plus bx plus c, and a, b, and c represent different numbers. Also, if you are given a quadratic that's not in standard form, you're going to need to rewrite it in standard form, which we'll get to in a little bit. So in previous lessons, you have been given things that look like this: x plus 3 times x minus 2, and you had to FOIL it or use the distributive property to rewrite it in standard form. Now I'm giving you something in standard form, so x squared minus 3x plus 2, and you have to rewrite it into the two binomials here. So your goal is to get a set of parentheses where you have x plus or minus a number times x plus or minus a number. And your job is to figure out whether it's plus a number or minus a number. So it won't actually be the plus or minus symbol. That's what you're trying to figure out. So in order to do that, you are going to first list the factors of C. So those are any two numbers, whole numbers. They can be positive or negative that you would multiply together to get C. Then choose the two factors that you can add together to get B. Those are going to be the blanks. So whatever those numbers are, that's where you'd fill into these blanks here. And step 3, which is kind of optional, you can check your answer by FOILing. So you can go back and FOIL it to see if it gives you the original one. So that's a way that you can check your work. So if the directions say to solve it, or if it has like an equal sign, you would factor first, then each set of parentheses equal to 0 and solve for x. This is what we did in the last unit. You will almost always have two answers. Sometimes you'll have one, but almost always two. So I'll show you some examples. So what we're going to do, the rest of the video is just going to be me solving some examples for you. So for number 3 here, first of all, we look at C, which is positive 44, and we want to list the factors of 44. So what you can do is just out to the side kind of make yourself a little table. So 1 and 44, 2 and 22, 4 and 11. Those are our factors. Now, we want to multiply them to get a positive, but add them to get a negative. So that means both factors have to be negative for that to be possible, because when you multiply a negative times a negative, you get a positive. So looking at these, if I add here, I would get negative 45, here would be negative 24, and here would be negative 15. So that means these factors here are my winners. So I would just write x minus 4 times x minus 11. That's plugging these in. Now again, you can FOIL this to see if you get back to your original. And if we did, it would give me x squared minus 15x plus 44. So on the next example, we have 120 and 22. And the nice thing about this is they're both positive. So that means when I'm solving it, we're going to be adding and you don't have to worry about the negatives. Now, when you're listing your factors, you can use some common sense here and say, okay, 1 and 120 isn't really going to be something that I'm going to use, and 2 and 60. So you can do some mental math here. So I'm going to actually start with 6 and 20. And 6 and 20, we're at 26. Then I'm going to try 8 and 15. We're at 23. So then I kind of start thinking about it, and then I'm like, oh, 10 and 12. If I add those together, that's going to give me 22. So that's what I'm looking for. So also, you might just look at this and say 120 is 10 times 12, and that's 22. You don't even have to make the table if you can figure it out without it. So now that I have these, I just fill in my blanks. So x plus 10 times x plus 12, and that's my final answer. Now, those are for when the directions say to factor. When the directions say to solve, that means you're actually going to get an answer. So x equals something. So in order to do that, you first have to put your equation in standard form. Right now we have the negative 84 on the right side of the equal sign. We need to move it over to here. So to move it, we would add 84 to each side and rewrite it as x squared plus 19x plus 84 equals 0. This is what we're trying to get. So now we would start listing our factors of 84, and you can, again, start with 1 and 84 and list them all if you want, or you can kind of do some thinking about it, and we're trying to get 19, which would be 7 and 12. So knowing that those two add up to 19, I would write x plus 7 times x plus 12 equals 0. Then to solve, you set each of them equal to 0. So you would get x equals negative 7 and x equals negative 12. So that's your final answer for that one. Same thing on number 10. You would add 56 to both sides. So x squared minus 18x plus 56 equals 0. Now here's one of those where we have a plus sign and a minus sign. So that means when you're listing your factors of 56, they're both going to be negative because we want to get a negative 18 here. So 56 is a little tricky. You may not know all the factors of that one. So again, just start listing them, and you can use a calculator to do some division here. But what eventually you're going to get to is 4 and 14, which are both negative, again, because a negative times a negative gives us the positive 56, and a negative plus a negative gives us the negative. So x minus 4 times x minus 14 equals 0. Again, set them both equal to 0 and solve, so you get x equals 4 and 14, and that would be your final answer there. All right, the next section of the tutorial is going to cover lesson 21.2, which is when a is greater than 1. This is definitely more complicated, so it's going to take a little bit longer. The goal, however, is the same. But what you have to look at is that you're multiplying A and C together. So that's where it gets tricky. The way that I'm going to show you is to make a table. The goal here is that you're going to have blank x plus or minus blank times blank x plus or minus blank. So before you only had to figure out the second blank, but now we're going to have numbers in front of the x. Also, it's very important that you see if you can factor anything out first. This will make the problems a lot easier to solve. So looking at this first example, I have 6, 5, and 1. There is no common factor, so that means I can't simplify it, so I'm just going to start making my table. So what you do when you make your table is you list the factors of A, the factors of C, and then you are going to multiply the outside and the inside. So you're practicing the FOIL to see which one is going to give me this 5x. So for A, I have 1 and 6 and 2 and 3. Those are the factors of A. For C, I'm really lucky because I only have 1 and 1. So when you are doing the outside and the inside, normally we would need to flip the order, but since we have 1 and 1, we don't need to flip the order because it would be the same no matter the order. So pretending that this is a function or a quadratic and I do the outside numbers, that would be 1 times 1. And the inside numbers would be 6 times 1. Add that together, you would get 1 plus 6, which is 7. So unfortunately, that's not the right one. So let's check the next one. Outer would be 2 times 1 plus the inner is 3 times 1, which would be 2 plus 3, which does equal 5. So that's the one I want. So here's now how you take this and write it as the factors. These two factors are going to go in front. So 2x and 3x. Put them in the order that they're in the table. Then the second two are what's going to be C. So they're both positive. So plus 1, and there is our factored form. Okay. Now 2 is a little more complicated, and if you look at our numbers, 3 can go into each of them evenly. So I'm going to do that first. So dividing every coefficient by 3, we would get 3 on the outside and then 3x squared plus 11x plus 10. So now making my table, I'm going to list the factors of A, the factors of C, and then we have the outside and the inside that we're trying to add to get to 11. So for A, we only have 3 and 1. Those are the only two numbers that you can multiply together to get 3. But remember, we want to list it both ways for our factors of C. So we can do 3 and 1 and also 1 and 3. So for 10, we have a couple different options. We have 1 and 10. And then we also have 2 and 5. So then that means you need to do it both ways. So 2 and 5, and then 1 and 3 times 2 and 5. So again, I'm switching because the order does matter, because in the first one here we're doing 3 times 10, but the second way we do 3 times 1. So the outside here would be 30 plus the inside, which would be 1. So that doesn't work. Then the second example, the outside would be 10 plus 3, again 13, so close but not quite. Then if we do this example, 3 times 5 would be 15, plus 1 times 2, which is 2, so 17, so that doesn't work, so hopefully the last one does. 1 times 5 would be 5, 2 times 3 is 6, and that does give me 11, so that means these are my factors, and I want to do them again in the order that's listed here. So we have x, 1x, so I'm just going to write x by itself, and then 3x, and then the second numbers would be plus 2 and plus 5. So this would be your final answer. Now, when you're solving, and I'm only going to do one of these just so the video isn't super long, we are going to do the exact same steps that we did above, but we're going to set our final answers equal to 0 and solve. So for number 9, looking at 5, 18, and 9, there's not anything that goes into each one of them evenly. So I'm going to make my table. Factors of A are 1 and 5, or I could write it 5 and 1. So now I'm going to do the factors of 9. So 9 would be 1 and 9, 1 and 9, or 3 and 3. Now this one, I don't need to do the 5 and 1, 3 and 3, because you'll get the same, because these two are the same, you would get the same thing. So you don't need to do that step. So again, we're doing the outside plus the inside. So the outside here would be 9, inside is 5. So that gives me 14, so not 18. The outside here is going to be 45 plus 1, way too high at 46. So we hope that this last one works. So 1 times 3 would give me 3. And then 5 times 3 gives me 15, so that does equal 18, which is what we want here. So again, to write it, we have 1x, which would just be x, and then the second half would be 5x, and then we have plus 3, plus 3. So then to solve, we set each of those equal to 0 and solve, which is what we did in the last unit. So subtract 3 from each side, you get x equals -3 and -3/5. And that's how you would solve those.